Welcome everyone to this new edition of the Continuous Testing Meetup online. Today we have a really good talk by Zach, but we're gonna go first with the quick intro we usually do. First of all, as usually, if you haven't checked our latest events, please go to continuoustestingmeetup.com and you can see all the upcoming events, all the previous events, if you want to check the recordings and in the recordings, the slides and so on, please have a look. All the information about the meetup, the Slack group, everything is there. We want to thank the sponsors, obviously Sauce Labs, for giving us the resources, for giving us the time to do all these events online, and also to Trending to support us by supplying and helping us promoting the event, and also having a new section in our meetup today. So we're gonna jump to our new section today, 5-minute vocabulary with Oksana. So I will stop sharing my screen and let's hear what Oksana has to share for us. One moment, please. There you go. Oksana, do you want to?
So hi everyone. My name is Oksana. I work at Trending and live in Berlin. So in our project, sometimes we use different terms or different definitions with our colleagues or with customers, but actually want to describe the same things. And Diego, Severin, and me, we thought it probably will be a good idea to give a short explanation of some terms in software testing. And that's why now we have 5 minutes vocabulary with me. And I will explain today the difference between errors, defects, and failures. And for sure, if you're looking, you can find a different definition of this term. So in my definitions, I will use IS2QB glossary. In case you don't know, IS2QB, it is an International Software Testing Qualification Board. So you can get a certificate as a certified tester from foundation level as expert if you have interest on it. And IS2QB glossary, it is a standard glossary of terms used in software testing. So here's just a small short chart with different certifications that you can give at IS2QB, but let's start with our definitions. So the first definition is error. In case you work in German-speaking project, it is Fehlerhandlung. It is a human action that produces an incorrect result. For example, a programming error. Error may have different causes, for example, time pressure or new technologies, or if you're new in the project, it's for you it will be difficult, or probably you will produce more errors in your code if you work with the new technologies, or you have misunderstanding about interfaces, exactly, especially in a project with a lot of with a development by different companies. So in this case, a person will introduce a defect into software code or in the data or the configuration parameter. So the next definition is defect. We can also find a bug, call it as a bug or as a fault, or in German language, Fehlerzustand. It is a flaw in a component or system that can cause the component or system to fail to perform its required function. For example, we can get an incorrect statement or data definition. Interesting is that we can find defects through static testing, for example, through code or specification reviews, or we can also have some defects in code that will never be executed, so we'll probably will not find it through dynamic testing, so through execution of code. And now we come to the next definition is failure. It is a defect if uncounted during execution. So actually it is an executed defect. People can make errors which might lead to a defect in a test object. So I think you know about it. And defects may cause, you can make a defect in a requirement. So it can lead to a wrong design, or a wrong design can also lead to a wrong code. In execution, defects may cause failures, and failures can be a false positive or a false negative. False positives, it is actually failures that causes by wrong data, or you use an old version of test data or old specification. So it is actually not really false. So it is a fault in your test case, for example. Or a false negative, in this case, it is the opposite. That is a test that do not detect a defect. So, and it is important to find and to fix these faults. So here, the short summary for our 5 minutes vocabulary. Errors made by people cause defects in the software, and which in turn may cause failures in execution code. And failures may be false positive or false negative. So thank you all. And
oh, that was quite nice. Thank you, Oksana.
yeah. Did I stop sharing my screen?
Yeah, you did. I'm now sharing again. So yeah, thank you very much for this quite nice 5-minute vocabulary with Oksana. It's a new section we are trying to put in the meetups. But without delaying more, the main event, we're gonna have Zach today talking about how to set up your team for success so anyone can write tests. Zach has spoken in several major conferences, testing conferences. I met him, I think, 2 years ago for the first time in the Selenium conference in India. Great person, nice guy. I also saw him last year in Chicago. Great host. So if you ever go to Chicago, he's one of the great guides of the city. So don't doubt to Slack him in the Slack workspace to get tips about Chicago as well. So I won't delay the introduction anymore. So please, Zach, welcome. Thank you for taking the time to do this, and the stage is yours. Thank you.
Thank you so much, Diego. Let me figure out how to share my screen really quick. Cool. I assume everybody's seeing the presentation?
Yep, that's good.
Cool. Thank you, Diego, for the introduction. As Diego said, I met him 2 years ago in India, where I was complaining about Selenium Grid, and he earnestly listened to my complaints and helped me figure out the issues I was having at my own organization. So Diego is also a great guy, and thank you for inviting me to give this talk. Really excited to deliver it to you all. Can't say I've ever given a talk to a German audience. So this is a unique experience for me. And please hit me up if you're ever in Chicago. That is true. And also thank you, Oksana, for the vocabulary session. I'll try to use the new vocab in the talk, and if I make a mistake, please call me out.
For sure.
So without further ado, so a little bit about myself. So my name is Zach. These are all my links. I'm Snack Addis in a lot of different places. And I work for a company called Review Trackers in Chicago. I also administer the Chicago Selenium users group. So we also have talks that we give on Meetup. And please, I would love it if any of you attended our talks. We have one in like August 5th, I believe. Actually, I believe the one on August 5th isn't a talk. It's a it's like a community session where people like bring their issues and we solve them together. So I'll drop a link in the continuous testing meetup Slack. And yeah, feel free to join. So that's me. So here's a brief agenda for the presentation. I'm going to be dividing this into two parts. First part, tips for failing transparently. Second part, tips for creating a culture of testing. And again, these two concepts are so that the end goal is that anybody will be able to contribute to tests and will be able to understand tests. We're trying to make tests more transparent, more understandable, more clear about what's going on, all of the above. But there's kind of like two different categories of that. So before I get into the tips, I'm first going to describe a scenario that you probably have all found yourselves in. So it's late on a Friday. The test engineer who wrote the test is out for the day. There's a person deploying. They need to get their change out on that Friday because they're out next week, right? So they need to get it out. They need to clear their work slate. They're working on this service called the Space Authority. Seems pretty cool, right? Except when they merged it into the staging environment, they hit this test error. They have no idea what's going on because it's kind of confusing. And they're like, I didn't actually touch this part of the code. And I've seen this fail before, maybe when I was running it on my local, and it wasn't a big deal. So we're going to ignore it and move forward. The test engineer's out for the day. We're going to go ahead and move forward. So they do end up moving forward, and it turns out, oh yeah, and then other people also, give them the thumbs up. They run the scenario by other people. Other people are like, I've seen that one be flaky. Like, it's cool. So they get kind of institutional buy-in. And then it turns out the Space Authority code that they touched is in charge of, protecting the planet, and the planet is destroyed. So you've probably been in that scenario. A test maybe reported something correct, but it was identified as flaky. No one knew what was going on. People moved forward, led to issues. So we want to prevent that scenario, that horror story. So here are kind of the 6 things that I'll be talking about in terms of making sure that we can avoid that horror scenario. First one is failing clearly. So something that I've noticed, I've written test assertions in Python, JavaScript, and Ruby. Those are my main 3 languages. What I've taken away is that different assertion libraries make failures look very different. And that can be kind of unnerving. It's possible that the Space Authority writer wrote most of their service in JavaScript and a little bit in Ruby, and the part that was in Ruby failed, and they're not used to looking at Ruby assertion failures. They're used to looking at JavaScript assertion failures. So the thing that I want to instill in you all is that you have the keys to your own castle, and you don't have to be beholden to what an assertion library does. So in this case, I'm just giving you some various examples of like different assertion libraries. So then this is PyTest. PyTest is pretty cool because you can provide a third argument in your assertion that tells it what is the error message you want it to say, which is a pretty cool thing. A lot of assertion libraries have additional arguments where you can give specific error messages. This is the assertion library that I use at review trackers. And we have some issues with it. So this one on the left where it says expected has text first name to return true, got false. I don't think that's a really helpful error message, because what I would want to know is what text it actually returned, not that it didn't match the expected text. So I would ideally look for the extra argument to provide to that error message to make it to do some introspection on the SMS preview object and have it actually return the text that it got in the error message. So that's an exercise that I like to do with my test engineers. And then the one on the right, unable to find a specific CSS selector, that's a great error message. I think that's really clear about what's going on. Someone at a glance can understand how it actually failed. Yeah, so another thing that, another topic associated with errors in general is knowing the difference between the different kinds of errors that a test suite can produce. So there are code errors, there are assertion errors, there are Selenium API errors, there are, you know, segmentation faults in your language that you're using. Like it's really important as a test engineer to understand the different classifications of errors that can occur. In this case, this is a no method error, which means it's a programming error. It's not an assertion error. And I think that's the most important thing when you're identifying test fails, is like instantly knowing if it's, you know, a programming error, is aka like an error in the test itself, or is the assertion you're expecting actually failing. So when you're doing that triage, that's kind of the first step. All right, so yeah, these two topics are interrelated, custom failure messages. So as I've kind of been saying, whenever fail happens, it should be clear it went wrong. And another thing I'd like to instill is, if failure message doesn't cut it, make your own failure message. These libraries that I'm showing, the one on the left, Python, right, Ruby, again, they have extra parameters where you can describe what went wrong. And you can do a little bit of introspection. And then one other topic that I don't have in the slide here, one other thing you can do is you can always do the begin rescue. If your library doesn't allow you to provide custom failure messages, you can rescue the thing that is possible to fail and then have it fail in your own way that you own. So I do that many times throughout my test suite. I also have kind of introduced my own custom assertions, so that I can have custom failure messages, things like that. We just want people to know at a glance what went wrong. We don't want to send them down into a rabbit hole looking for the problem. So those are those two topics. Next is using status checks for the services your tests depend on. So imagine this scenario. You have an end-to-end tests. The endpoint you need for your test is down. But the test doesn't directly use that endpoint. It does maybe like a front-end action, and that endpoint is used downstream. And then let's say that test fails. That can be a really hard thing to investigate, because there's an indirect dependency that's causing this failure. So a thing that I like to do in my test suites is have status checks for every service that's needed for the test. So the screenshot here is, this is an example of a test that I have at Review Trackers, where we use the service called Falcon. It's an indirect service. So we're not using, it's not an API test. Again, it's an end-to-end test. It's a dependency for the data to show up on the page. And we just ping its status endpoint at the beginning of every test to make sure that it's up. Because if it's not up and the page renders and there's no data, that again will be a rabbit hole of investigation. You'll be wondering where it broke down. It can break down on the front end portion of it. It can break down in any layer of the stack. So I would highly recommend, if you take nothing else away from this talk, please add status checks to your tests. They will save you so much time. You'll appreciate that you have them. So next topic, test reports. I love test reports. Test reports, there's so many good options out there for each one of your test harnesses. This one on the right is the one we have at Review Trackers. It's this gem called the RSpec HTML reporter. It formats the stack trace really nicely. It shows you the source code of the test and where it failed. And then it gives you, it embeds like the screenshot or the video in the HTML page. I think that it's worth your time to have nice test reports. Why is that? It's not just a nice to have. It's like, if someone is in that failure scenario on a Friday, and it's already a very stressful scenario, it'll help them if there's some nice design associated with the test failure, so that they can, at a glance, try to triage what's going wrong. So I think test reports are really worth investing in. Another thing that we do at Review Trackers is we have a test reporting solution that provides test analysis across test runs. So that gives you kind of a snapshot of like test health. You know, like maybe over the course of a day, how many times does one particular test fail? And is that maybe we need to the test engineers need to dig under the hood and investigate that test to see if it's flaky or anything. So we at Retrackers use a software called Report Portal. I'd be happy to talk with anybody offline about Report Portal. I'm a huge advocate. We use this widget religiously at Review Trackers, where this just tracks failed tests across the last 30 runs. And then if any test is outside those bounds, you know, it goes above 10%, then we usually investigate. So second last thing, using a test logger. So what is a test logger? Test logger is just like, you know, like a production logger. It lays out the important steps in a test case. So for Review Trackers, things that I like to use a test logger for is the actual step of logging into Review Trackers. I always log that for each of the tests. And then if there's something complicated going on in the test, I'll log the steps as the test does that process. I think that's really important. It's important because when you're triaging a test fail, you can see, you know, did the test struggle to fetch the reviews? Did the test make it to this particular point? It's a really useful tool to use. Let me see if I can give some other examples. So another reason why to use test loggers is because sometimes fails only happen when you're running a large number of tests in parallel. So that can be like hard to reason about. So logging more things will help you investigate. And then let's see, I'm gonna skip this slide. This is just like I'm just showing some examples of things that I've decided to log out to help me investigate certain fails in CI. So we had a scenario where the data wasn't changing when we would change the time period on this chart. And I couldn't reproduce it in my local environment. And it turns out that it was an issue with actually changing the date, but I was able to kind of get more granular about that issue by just logging out what the test was seeing for those table numbers. It just helped me investigate. So it's kind of, test loggers are similar to like videos. Like if you have a video of the test, that can help you investigate greatly. But something that the test logger does that's better than the video is there are timestamps correlated with the test logging steps. And a thing that I like to do is correlate those timestamps with the software under tests logs. And that can really help you drill into issues, is if you have your tests logs and the software under tests logs, you can really drill into the breakdowns when they occur. And you can't really do that with a video as easily. So that's another reason to use test loggers. Another thing we do at Review Trackers with their test loggers is we log out the credentials of the test accounts that are used for the test. So if a test happens to fail, you can log in and see the state of the system at the point of the test failure. That's hugely beneficial to be able to reproduce issues. So yeah, that's another thing we use the test logger for. The last thing with this topic is saving test artifacts. If your test grabs emails, saves PDFs, CSVs, etc., save all that data somewhere and put it on a file server that's accessible after the test run. That's really important to investigate fails with any of those files. This is something we do at Review Trackers as well, and we've been able to quickly solve PDF rendering issues and CSV data issues by actually having the copy of the CSV that is downloaded by the test. This is an example of a test run that we have at Review Trackers. We use Slack for kicking off tests, and it'll the Slack report will give you a link to the Jenkins console log. It'll give you a link to the HTML report, and it'll give you a link to the test artifacts, which is all those PDFs, CSVs, etc. Here's a GIF of me logging into the file server, and I'm looking at the PDF that was downloaded and looking at all the emails that are sent out. Yeah, I think this is a really valuable thing to do to, again, fail transparently. Okay, so that's the first half of my presentation. I'll stop really briefly for questions. If anybody has any questions about any of those topics that I just discussed, and I'll bring up this right here.
Sure. There was one question from, I don't know if I can pronounce this, Aurelian. And he or she asked if logging too much can be an issue, like that you just get swamped in all the logs if you get every kind of transaction from both your test and your server and put it in one place. It might get overwhelming.
That's definitely a good point. At Review Trackers, we attach tags to all of our logs so that you can easily filter the test services logs versus the software under tests logs. It's not all being dumped in the same place so that they can't be separated from each other. And then another thing I'll say is like logs are really helpful when they're very specific. Like they're done for a specific purpose. If you're logging just to log, then it creates noise. But if you log in a way that the messages are specific, and in my case, like the test case that is being run is part of the log, so you can filter on a specific test cases logs. Like being able to filter across the logs is really important. If there's just if it's just a bunch of dynamic disjointed information, you won't be able to make conclusions based on it. So like use the same guiding practices that you would in a production log in your testing log. In production logs, often you might log like the process might be part of the log message, or like the service that's being used for the log message, the files, you know, stuff like that. Use all those same practices.
And you keep all that stuff forever, or just for when something goes wrong, or how does it go?
We, I think, keep our logs for like 7 days.
Okay, yeah, sounds reasonable. Okay.
And then we dump them into like, we actually use Datadog, but before we use Datadog, we had our own Elk stack, our Elasticsearch stack. So they're all searchable, which is really nice.
Okay, cool. Then I have a question myself. You talked about the classification of errors, that you should be able from the log to see where it's coming from what direction. Do you have any tips on, like, let's say you're in a new project and you're not super familiar with their frameworks that they're using, you might be able to differentiate between the 2 or 3 languages that are used, but other than that, you don't really know much about the project yet. Are there any like base types that you immediately know this type of error comes from, I don't know, someone used the wrong variable type or something? I don't know.
Yeah, that's a good point. That's a good question. I think Google is your friend at that point. You know, usually with like a stack trace, you get like the class of the error and then the error message. And then I usually search for like the class of the message in Google, and that'll get you information on like that kind of error. As well, in the Selenium source code for Ruby, at least, there's like a file called errors.rb. It's a Ruby file, and it just has a list of all the potential Selenium errors.
Cool.
So you can do that exercise too with whatever library you're using. You know, see if that library, hop into the source code, see if there's like a collection of the errors that are possible for that library.
Okay, thank you. Does anyone else have any questions? You can just unmute yourself. Okay, then I would say go on.
Cool.
Thank you.
Okay, so now we're on the second part of the presentation. And what is the second part? I forgot what it's called. Tips for creating a culture of testing. That's right. So here's the scenario. I'm going to lay out another kind of horror story. For for creating this culture of testing. So it's early on a Monday, and I am an app developer, and it has been told to me that this form needs to have 10 stars, not 5 stars. I'm like, oh, that's so easy to do. I know exactly how to do that in the front end code and in the back end code. That's so easy. I'll do it really quickly. Oh, I guess I got to update tests as well. You're really excited to get into those tests, go ahead and update them. And then you look at the test and you're like, what is this test doing? I thought this was a simple feature. Why is there this crazy SQL query involved in this test? I have no idea what's going on. Okay, I see the 5 stars, but I'm still not really sure what they're doing in this test. This is real review trackers code before I worked there. And you just lose all motivation because you're like, why is it? It's easier to write the feature. It's easier to extend the feature than it is to write the test. I've lost all motivation to editing this test. So this is you after doing that. So we want to avoid that scenario. We want to make our tests easy to contribute to. We want to create a culture of testing. We want that excitement that you had to expand those 5 stars to 10 stars to be, you want to have that same excitement when it's time to change the tests. So here are some tips that are, programmer facing, and also just like they're kind of creating a culture of testing, creating a culture of practice around the testing, creating these practices that will get people jazzed about testing. So first thing in this topic is easy factories. So what is a factory? Factory is just a way to insert kind of mock, or to insert data in your environment that your test will use. So factories, some tips that I have to make factories easier is they should always have default arguments and they should be easily configurable. So at review checkers, I have an example of a factory that we have. It's like a master factory. It's called account with various users. It's one line of code. It creates a new account. It creates 7 users, 30 reviews, 12 locations, 3 groups, 5 templates. It creates all this different dynamic data in the environment. But it also is configurable. So I can, if I wanted to only create 1 user, I can provide an argument to have it do that. If I wanted to not create reviews, I can provide an argument to do that. If I wanted to create 12 locations, but have those locations not have reviews, because I'm testing a new splash screen that occurs when you have locations but not reviews, you can also do that. So you can configure each of the pieces to get in the state that you want to be in. A sign of a good factory is when developers or QA engineers use it to create data for doing specific manual test cases. I think that is a quality factory. With the factories that we have review trackers, there was a time when we needed 100,000 reviews, more than 100,000 reviews to test a specific chart. And we used the factory to create all those reviews in less than 5 minutes. And we were able to do that test case really quickly. So you gotta aspire to that. You know, that's the pinnacle. Okay, next topic, damp, not dry. I'm sure you've all heard of dry, don't repeat yourself. It's a common programming phrase that you'll hear, but I would posit that with testing, it's important to be damp, not dry. Damp is descriptive and meaningful phrases. So why do I think it's okay to repeat yourself in tests and just be descriptive? And I think that's okay. It's okay to repeat yourself is because the focus in tests should be on humans reading the code, which means you should be able to copy and paste code so that it's easy to contribute to the repository. Let me kind of give an example of this. So let's say you're working on this. So you have the stars feature and you're working on another feature where instead of stars, it'll be like 1 to 10 instead of 10 stars. So that feature is pretty similar to the stars feature. I would posit that when you're writing tests for the 1 to 10 feature, you should copy and paste the code from the stars feature and tweak it slightly, and then continue off on your way. And I think that's an okay practice to do in a testing repo. Yeah, I would say that's totally cool. You should look at other areas that are doing similar things, extend them slightly, tweak them slightly. Call it copy, paste, replace. And then just another idea. I guess I don't have this in a bullet point for damp not dry, but you want your method names to be very explicit for what they're doing. So like if you would want to have methods, like a method that does a lot of things, like say like click, accept, and navigate to next page. If that's an action that you want to extrapolate into a method, have that method have that full name and let the method describe exactly what it's doing. People might complain about things like that in a production repository. They'd be like, why don't you, dry that up or things like that. But I would say, don't do that. Okay. Next topic, documentation for contributing. We want to make it easy for people to contribute to the tests. So why do I think we need contribution documentation? It's because Selenium is not easy to use. It has a lot of quirks. These are some articles that show how tricky Selenium is. Yeah, I'm sure people have encountered this before. This is just a snippet of the WebDriver specification for like what happens when Selenium executes a click action, and it's really complicated. And there are a lot of nested steps. And why am I describing all this? I'm describing all this because you at your organization probably, as a test engineer, you've probably figured out the best way to do clicks. You should describe that in a document somewhere so that other people understand why you're doing clicks that way, and then they can do clicks your way. So here's some examples of documents that we have at Review Trackers. I have a test architecture doc. I have the tips and tricks for Selenium, which is where I put those, how to click documents. I describe how the tests are run in CI, because the CI infrastructure is a little different than the continuous delivery infrastructure. Tips and tricks for the factories, how to structure a test. All these documents make it so easy that for developers to just jump in and write the tests. Here are some examples of some helpers to make Selenium a little bit less daunting. Scroll within allows you to, like, let's say you're in a modal and there's like a scroll bar that's not the page scroll bar, but like the scroll bar of the modal. That method will allow you to do that. Scroll to just allows you to scroll to anything on a page. Yeah, and we don't want every engineer to write their own scrolling code. So, provide easy utilities so that people can do what they want to do easily. Here's another example. So use, modern coding practices as well. Like I have a kind of a tiny doc string where that shows an example of how this method is used right in the method. And people do that, sometimes in production repos, and they have comments and documentation. Do the same thing with Selenium or with your test repository. Yeah, here's an example of a doc string that I have that just explains all the arguments for this utility that I provided. Developers will be more willing to use the utilities if they know what it's doing. So another way to create the culture of testing is to have documentation on the services that the tests actually use and like how to investigate those services. So, that, let's say like in the example I gave earlier with the stars, there's a service that there's a microservice maybe that records the API action of like clicking 5 stars or 10 stars. And in this example, like there would be a document on how to log into that services database and like investigate there. That way that someone who's not an expert in that service would be able to investigate. Here's some reasons why to do that again, because like when a service is down, it's really high pressure. You don't want that to be the time to be learning about the stars service. You want to, be able to solve the problem quickly. So if there's a document that just like explains how to investigate those various services, it can help a triager feel less stressed. We want to empower people to be able to figure out what's going wrong, like for themselves, and be able to investigate. And this is, in those cases where maybe your error messages describe part of the problem, but like you might want to find, more data to back that up. At Review Trackers, we have like a general guide of what to do in these high pressure scenarios. So we tell people to repeat the test workflow, see if the issue is like consistent or if it's flakiness, check the workflow in staging and in production, check if the affected service is having an outage. Again, those service status checkers are really important. Check if any alerts have gone off, check if their status pages. We also keep a log of failures that happen, like maybe in a bug triage system or in a wiki or in that report portal service. And you can look there to see if it's like a regression, if it's something that's happened before. And like we have this as a checklist so that, again, the person who's triaging is maybe less stressed and they just like have a place to look for what to do in these scenarios. Okay, next tip, strong programming paradigms. I would posit that it's important to treat your test code like you would treat production code. What does that mean? That means turn on the same linters that you'd have for your production code, have the same naming conventions, structure your files in a consistent way. If you do this, there's less context switching for the developers to contribute to your test repository. They're familiar with writing all the production code. So if your test repository is structured in a similar way, it's just so easy for them to hop in and write a test. Some other paradigms, like other people should be able to read a test and know what's going on. Test code is code, treat it like code. In general, I'm just not a fan of thing one or thing two variable names. I like names that are consistent with the outcome expected. And again, use the DAMP ideology, descripting and meaningful phrases. Like your variable can be huge. I'm fine with that as long as it's descriptive and easy to understand. Some other things that I try to instill in my junior test engineers is to avoid conditional logic in test cases. I think it becomes hard to reason about if your test does different things in different environments. Or if your test is handles dynamic data or something like that, where like maybe if your test, if there's a 1-star review, it does one thing, and if there's a 5-star review, it does a different thing. Don't have one test do 2 different things. Have one test do one consistent thing. If you need to have conditional logic, you should abstract it away into your helper classes in a way that makes sense. But try to avoid it at all costs. So let's say you have tests that are different in CI and CD. I would posit you should actually copy that test file and have that test be 2 separate tests. One that's specifically run in CI and one that's specifically run in CD. And it's okay if there's a lot of overlap in those 2 tests, but that's again to avoid the conditional logic. It's kind of a radical opinion, but we do it. So, okay, second and last thing, be a respectful code reviewer. So you are probably a test expert. Other people are committing tests. They might not be test experts. Test expertise is a gained skill. It's something that you've worked hard in your career to achieve. So it helps to go out of your way and make people committing to your repository a joy, make them have a joyful experience. So I would say, yeah, be as respectful as you can to people writing tests. They're going out of their way to write tests. Tests can be hard. We just want to instill goodwill in the act of writing tests. It's almost like donating to a charity. I just think, yeah, it's important to be really nice. And then think about it this way. If you have the developer's goodwill when they commit to the test, when things aren't going well test-wise, you have people's forgiveness. Like if a test is flaky, maybe because something you introduced, people will be like, well, you helped me that last time write the test. So no big deal. We'll help you out. Yeah, you want the developers to be your allies. You want them, you want to foster goodwill so that there can be this reciprocity. These are just some various articles about PR feedback. Whenever I give feedback, I always frame it as like we, like I'll say things like we benefit with a for loop here, that'll be a little bit cleaner, or and I think it's better to use we than I, because really we would benefit as in like the organization would benefit, like our team would benefit if we had this clean coding practice, not just like, it's not just what I think. Like this is an action that will help everybody. All right, so that's the respectful code reviewer. Last thing is to have a process for putting tests on the bench. This is something we do at review trackers. You might be asking yourself, what is the bench? As we know, Selenium is flaky, like kind of inherently. The idea of the bench is it's a process for pending test cases that are like newly flaky, so that test issues don't turn into test bottlenecks, and test issues don't prevent people from getting things out the door. So we have rules about benching at review trackers. Our rules are if a test fails twice in the same exact way, if you can identify that the test is not failing because of the software under test, but because of the way that the test is written. If you get the approval from one other developer, you can put a test on the bench, and what that means is it's pended, and what that means is you can move forward with your deploy, you can move forward with whatever you're doing, and then the test engineers will figure out how to fix the test. And then that'll be like priority number one. Yeah, oh yeah, here's my rules. Yeah, some other rules are the test must fail, the test mustn't fail because of newly released functionality. Because if the functionality is new, it also means the test is new, and there can be issues in the actual functionality that are not transparent and things like that. So in general, if it's newly released functionality, we usually keep the test there and try to really get down to the root cause like at that moment, as opposed to putting something on the bench to investigate later. And then some other rules, like once something's benched, we usually have like a SLA for like a day of like getting that test off the bench. Sometimes it's 2 days. We have some forgiveness when things are on the bench. Cool. So those are my tips for creating a culture of testing. Are there any questions about the presentation?
If you have a question, you can just unmute yourself and ask the question. I will just start with the question, if that's okay. You talked a lot about how to basically make this whole process easier for developers, but in most teams, there are also a lot more, let's say, business-oriented people or even the customer. Do you have any tips how to get them a little bit more involved? Because of course, this is now easier for developers, but I think there are probably also tools to get them on board, right?
Yeah, for sure. I'm sure a lot of other people might have better tips for this question. At Review Trackers, we're pretty lean in terms of business people and product people. Like we're like a developer-driven organization. But I'll say having the test names be really good is really helpful, because we've had the product people look at the test names and then they can understand the coverage, so they can like know if new tests need to be written or if we have good coverage in a certain area. Yeah, things like
especially if you have a pretty report that you put out, right? Then that makes it a lot easier to read the names of the tests.
Exactly. So yeah, that's a really important thing. And then again, with those clear failure messages, I mean, a non-expert should be able to understand what's going wrong. So in that service area, I'm sure your product person is like aware of Falcon and its purpose in the test architecture. So they'll be able to like look at the status page and see what's gone wrong in that particular.
Okay. Yep. Okay. Anytime anyone else has a question, just interrupt me. Otherwise, I will just ask the next question. So I had a customer who insisted that the testing team should be as separate as humanly possible from the development team. Why is your focus on the exact opposite? Of course, this is how the industry is going, but like, what are your arguments for someone who insists, no, you should not even talk to the developers if possible?
Well, I think that we want the developers to write tests because we review checkers trust the developers. And if you're not trusting your developers, then you might have a larger issue. And maybe that's why you want to keep the team separate, because you don't want the testers to get too guided by what the developers say. You want them to keep an open mind and whatnot, and like, you know, do as much black box testing as they can. And, you know, maybe that works at some organizations. However, I think if you trust your developers, no doubt your developers will understand the test coverage in the best way. They will know what are the important things to test. They won't be like, oh, you don't need to test this twice because it's actually the same component under the hood. So they're the ones that'll help you kind of determine, you know, the important things to test. They're the ones authoring the features. So if you have the person authoring the feature write the test, that's really full circle. And yeah, again, you'll get the best test case. So I like to be a consultant, right? I maintain the framework, I maintain the health, I help investigate when things go wrong, but it is the developers who contribute the bulk of the test cases, and we've had a lot of success with that.
So you can focus on the special stuff, similar to how automation can help you focus on the special stuff. Yeah?
Yes.
Awesome. Yeah, cool. Yeah, any other questions? Otherwise, I have an idea for Oksana. Maybe next time a bug triage as one of the words that you could explain, maybe, because this happened a lot. I don't know if we have still time, if anyone wants to have another questions. Otherwise, thank you very much.
No, I have a question for Zach, because this looks like this is the compilation of lots of learnings. So maybe you can give us a quick overview of how things were when you started this job, and now how things are nowadays based on all this.
Sure, I can try to do that. Well, when I got to review trackers, there was one Selenium suite that ran for 30 minutes. It failed 80% of the time. And they would rerun it 4 or 5 times before doing a deploy. And there were some systemic issues in a lot of the test utilities. For example, you had factories that were, you know, inserting SQL, but a single quote character from the factory data would break the factory because a single quote is like a special character in SQL. Basically, the test code was unloved. It wasn't treated like production code. So people lost faith in the tests. So, you know, I got in and started working on the factories, started working on the test utilities, skipped a bunch of tests that I felt like weren't really helping anybody. They were just getting in the way. Focused on getting the suite green with the smallest amount of tests so that it could at least provide value. And then from there, yeah, just grew it and, you know, put in tools like Report Portal, which enables you to get a snapshot of the suite health so that people, you know, if you have a day where there's a lot of fails in the tests, people, like developers, can look at Report Portal and see, oh, it looks like the suite is having some issues. Is Zach investigating them? And then I'll get a Slack message. I'll be like, yeah, I've been doing that since yesterday. We're working on it. So yeah, I think it was a suite. It was a test suite where people would contribute to it and forget it, and there weren't like consistent programming paradigms. And once you make all that easier, it becomes easy to contribute to. And then now we have it as like, as an acceptance criteria of a ticket, it'll be like tests have been added for X and Y new service, and they can write the test before the code is deployed alongside the deployed code. That's the goal.
Awesome.
Cool. That sounds
Very
great.
cool.
Great. So let me take over the screen sharing. And right, yeah. Again, so thank you, Zach, a lot for doing this presentation. I think it was great. Like listening to the compilation of all your learnings through this process and a way to engage developers more into testing. So yeah, again, thank you very much. And thank you to Oksana for the 5 minutes. Thank you to Severin for all the questions and like handling on the Q&A and so on. So yeah, thank you very much, Zach. And I hope to see you in a future meetup.
Yeah, same. Thank you for having me.
Very cool.
Thanks, everyone.
Thank you.
Thanks, Susanna.
So yeah, before closing this one, then let me announce the next meetup. This will be on August 12th at 5 p.m. the afternoon, Berlin time. We're gonna have Aaron Evans from OneShore, his own company, but he works in different places. He's an ex-saucer. So he's gonna talk about GitHub Actions, some CI that has been growing a lot in the last couple of years, I think. So we're gonna see how he can show us to build the continuous feedback loop with GitHub Actions. That's it for today. Thank you everyone for joining and hope to see you in the next one in August 12th. Bye.
Bye.
Thank you. Bye.